I hope you guys can hear me. Yeah, I've just started sharing my screen. Let me know if you guys can see my screen.
We can see your screen that's sharing Adobe Connect right now.
Okay, great. Okay. So, hello everyone. Welcome to the session. I am Suchika Singh. I work for the ColdFusion product team at Adobe. I've been part of the ColdFusion team for about more than 12, 13 years now. So, I've worked on a lot of features with ColdFusion. Currently, I've been working on all the AI features with ColdFusion 2025. And today, I want to showcase you how you can start building intelligent applications using LLM or large language models using ColdFusion. Right. So the session is not theoretical. It will be more of writing codes, and we'll be actually building a real application step by step. So at the end, you will actually know how to build a production ready app and how to use these features in your production app. Right. So let's quickly, sorry. Yeah. So let's quickly go over the agenda. So here's the plan. We'll start with a small introduction on how LLMs work and what LLM is, and just enough to make a good engineering decision. So this is purely a developer session. So we will not be going into deep into knowing what LLMs are and on all the research papers related to LLMs, right? So we'll only be talking about all the LLMs and its config, which is important for a developer to make a choice on what LLM they should be using in their application and what configs they should be applying to their LLMs. Right, so we'll start off with that, and then we'll move on to the chat model API that we have with ColdFusion, which is used to connect to all the AI providers, and then how to configure that LLMs with CF Administrator. And post that, we'll be building our app, and I'll give you the base of what this app is supposed to do, and just then introduce all the features and the show all the limitations in the app, and also how to solve those limitations in the app. So let's quickly start. Okay, so what is an LLM? We'll start with that. Uh, so LLM is actually an AI system which is trained on a massive amount of data, which actually helps it to understand and generate human-like responses. So the core mechanism is basically to predict the next token based on whatever token it already knows. And this mechanism, repeated over a billion number of times, helps it to solve complex problems, write codes, and everything else that is possible with LLMs, right? So with LLMs, there are no explicit rules as such. Like as a developer, we tend to write a lot of rules in our application, right? So if the customer comes up with a query on a return, we go to the returns table, get the data from there, and then send it out to the customer. So we tend to write a lot of rules in our application. But with LLMs, there is no explicitly rule defined. It just learns from the billions of data that it has been trained on, right? So yeah, so no explicit rules. Billions of parameters. So parameters are like tiny knobs, which an AI model which resides inside an AI model, and it helps it to understand a language. So during training, these knobs are actually adjusted based on a huge amount of data. So more the parameter, more accurate and more smart your LLM is, and the lower the parameter, it might be faster and cheaper for you, but it is less accurate. So based on your production application needs, you can choose what LLM model to be used. Right. Also, LLM fundamentally are stateless. So by stateless, I mean that every single call to an LLM is basically a separate request, and it's completely independent. Model has no session or no cookies or no databases attached to it. So if you want the LLM to remember your previous conversation, you have to send the entire context with every single request. right? So LLMs are trained on large amount of data. They predict the next token. There are no explicit rules as such associated with LLMs. They're trained on billions of data, and every LLM is associated with the certain parameters based on which you can decide whether it's what is suitable for your application, and fundamentally they are stateless. Now that we know what LLMs are, let's talk about what shapes an LLM's response to the prompt that you give it. Right. So the first thing is tokenization. So whenever we send text to a model, to the LLM, it does not see words like we see. It just sees tokens. For example, cold fusion is a word to us, but for LLM, it may be two or three tokens. So the amount of so the longer your input and the longer your output would be, so you're charged on the base of your the token that you have sent and the output tokens. The longer your input and the longer your output are, you will be charged more accordingly, right? Context window. So context window is like the working memory for the LLM. So it includes your input prompt. It includes if you wanted to remember the previous conversation, so it includes the conversation history, and also it includes the model's response, right? So for example, the GPT-4 model can handle 128K tokens only, right? So this is exactly why we have chat memory, max tokens, and drag, because we want to manage the token window or the context window efficiently, and hence there was this need of chat memory, max tokens, and drag. We'll get to all of these later in the slides, what these are. Right. And finally, some of the configurations that control the responses of the LLM. One of them, which is one of the very important configuration, is temperature, which actually controls the randomness of the output. So if you give the temperature value as 0, it will give you mostly a very predictable answer, and as you increase the value, it becomes more and more creative. So if you're doing some debugging or something, I think then the temperature value should be close to 0. But if you want to write a creative poem or something like that, then the value should be more than 1 or close to 1, right? So sorry. Yeah, and then there are other configurations also related to LLMs, like top P and top K. So top P and top K is basically top K limits how many possible next words the model should consider, and top P limits based on the probability. These values mostly we leave it as default, and we don't need to tweak these much, because all the LLMs that we currently use have these values tweaked by default, and they work in most of the real world use cases. Then we have max tokens. So this is basically to put a cap on the output response that you get from LLM. So even if the model would stop even in the mid sentence if you have defined your max tokens as a lesser value. So it is important that you define this value appropriately. If you have lower tokens, it will stop abruptly and your response would be incomplete. And if you have higher tokens, it can become expensive. So it's important to set this value appropriately. So if remember all these points, you can optimize on the cost, speed, and also the creativity and accuracy of the LLM that you will be using. Right. So now we have a fair idea of how LLM and what knobs control the LLM's output. Let's see how we could use those with ColdFusion 2025. So these are the AI provider. This is the AI provider landscape that we support with ColdFusion 2025. We support almost all the major providers available in the market, which is OpenAI, Anthropic, Azure OpenAI, Mistral, Olama, and Gemini. So it's as simple as just switching the provider in the same function. So you just have to change the config values, and ColdFusion can start calling that provider for you, but using the same function. So what that function is, it is the chat model function. So inside the chat model function, you define a struct config, which has certain keys which are mandatory, like you have to define the provider that you want to use, what model from the provider. So based on the provider, this value would change. And then your API key, which is used to interact with the provider that you have used. And then finally, other configs like temperature, max tokens, and so on. Right. So once you have the instance of the chat model, you can call .chat method on that instance and then start giving your prompts to the LLM. It's as simple as that. And if you want to switch providers, you would just have to change this struct config to point to another provider. You can also define this chat model config under your CF admin console. And once you've defined, you can use those aliases with the chat model function, and then again use the .chat method to send your prompts. Yeah, and you can again use the same alias, and if you want to override some of the config parameters, you can override that as well by providing another struct along with the alias, and then start calling the .chat method. Right, so once you call the .chat method, it returns a response object, and we'll see how this response object looks like. It is basically a struct, and it has three keys. The message is the actual response that LLM is giving to your prompt, and then there are some metadata associated with it. There's a unique ID associated with each prompt that you send. The finish reason is stopped, so it has given you the entire response, and then what input token and what output token you've used, and the model name that was used in this prompt. There's one more key for tool execution requests, which we will see later in the function tool slides. Okay, so now that we know what providers we have and how we can configure them using the chat model, there are other chat model config parameters that you can configure. And by universal in the slide, I mean that these configurations would work with all the providers that we support. Right, so the first three are a mandatory one, like the provider, API key, and model name. API key is not required in case of Ulama, because in that case you would have the Ulama server running in your local system, and then you would need to give the base URL. So otherwise, these three are required parameters for all the providers. And then we have temperature, max tokens, top P, and top K, which we have spoken already about it, earlier in the earlier slides. Then there's response format. So you can tell LLM to respond in a particular format. We support text and JSON format, both. Then seed is basically to get a reproducible output. It's more used in debugging purposes. So if you give the same seed and same prompt to the LLM, it is likely to give similar responses. Then you have timeout max retries. This is basically to, for your production systems to define the timeout. So if you have long running prompts, you can increase the timeout, and you can also change the retry counts to more than 3 if there is a likely to be some failures in your system. Then there is stop sequences, which tells the model when to stop generating responses. It could be an array of strings of so whenever the model in the response and gets this kind of string, what is mentioned in the stop sequences, it will stop generating the output. Log requests, log responses, again, it is useful for debugging so that you know what's actually going under the hood. So if you enable it, you could see all the LLM related requests and responses that is going to the LLM from ColdFusion. All those payloads would be available on the ColdFusion logs. Right, so these are the config parameters, which is universal, which is available to all the providers that we support. There are some provider specific parameters as well. So for Anthropic, we have some of them being thinking type. So it has a concept called thinking mode. So the model basically takes an extra step before actually answering it. So when you enable it, it'll enable the thinking mode and take an extra step before it actually gives the responses. Then you can define the thinking budget. So basically, how much token you want to uh, waste on the thinking budget. So you can define that here. Then there is cache, which is basically prompt caching, which is also to reduce costs on repeated context. Beta flags, and then the temperature range is basically not 0 to 2 as in case of all the providers. It's 0 to 1 for Anthropic. Then Azure OpenAI. So since you do a deployment of the model, so you need to specify a base URL. You can specify the API, Azure API version as well using the service version key. And then we have max completion tokens. Most of the providers use max tokens, but with Azure, certain model series like the O-series model, you would be using max completion tokens as the config parameter if you want to define the max tokens. Then we have Mistral. So there is some inbuilt safe prompt enabled with Mistral. So like the guardrails is there is some inbuilt guardrails with the Mistral model. So if you want to enable that, you can set this parameter as true. Then there is frequency penalty and presence penalty. Frequency penalty is to reduce the repetition, and presence penalty is to encourage to have more new topics. Right. The range is again 0 to 1. For OpenAI, it's again -2 to 2. The ranges varies based on what providers are in the case of this config parameters. Again, the temperature range is 0 to 1 and not 0 to 2. Uh, then it's Olama. So in Olama, we have again the base URL based on where you've got the Olama running in which system, and there's no API key required. And then we have additional controls like num predict, microstat, min p, repeat last 10. So all of these gives you low level control, which is useful for local setups. Right. Then we have OpenAI. So for the models with O series, they use max completion tokens, as we have mentioned in Azure OpenAI, instead of max tokens. And in fact, GPT-5 does not even allow both max completion tokens and max tokens both. Then we have logit bias. This is to suppress specific tokens. So you can use that using logit bias. And then you can enable parallel tool calls using this parameter, parallel tool calls. Then there is strict JSON schema. It's basically to enforce a strict schema validation in the response that LLM is giving. Then there is metadata, which is just used for tracking purposes. And again, frequency penalty and presence penalty as mentioned in Mistral, but the range differs here. It's from -2 to 2 in case of OpenAI. And again, the temperature value is different than other providers. It's 0 to 2 for OpenAI. And finally, the Gemini. For Gemini, there is like four unique config parameters: candidate count, and stop sequences, safety settings, and response MIME type. Candidate count is basically you can ask for multiple responses at once. For that, it is used. Stop sequences is similar to what is available in Anthropic. Then safety settings is similar to what safety prompt is available in Mistral. So just to guard to avoid getting LLM responses based on harassment, hate speech, and all of that. And then the response MIME type you can change. You can again define as to only it can be either text plain or application JSON. So these are the only two formats that we support currently. Right. So yeah, so we've got a lot of config parameters with these providers. Uh, I mean, it could be difficult to choose what parameters to be set for what provider, but I mean, you can try out and see what is applicable for your application. Now, how you could configure LLMs in administrator. Now, we can define these configs using the chat model API, but there's also one more way of doing that. We can configure LLMs using the CF administrator console. So, what you can do is you can go to your CF admin and go to the new AI services tab we have. Under that, you have the LLMs page, and you could configure what provider, model name, API key, you can add that, and all other provider specific options that is available for this provider and store it in. What would benefit you with this? So API keys are not stored in your source code. So and you could change the model without even deploying your code again and again. You could use one alias across multiple CFM files, and the key rotation also becomes easy. It's just in one place. You go and update it, the administrator console. Right. If you do not have access to the administrator console, you can use the admin APIs that are available. So we have that multiple functions associated with this admin API that's available under the llm.cfc component. So you could set your LLM model or define your LLM alias using this function set LLM model, and then retrieve it using the get LLM model, and finally delete it using the delete LLM model. Right, we can quickly see how you can create the configs using the ColdFusion administrator. So I'll just go to my admin. So you can see a new tab for AI services. You can just go there, and under that you have LLMs. You can define your config name, select which provider, and just do an add, and it gives you what parameters are applicable for that provider. You can all add all those values and save it. And this would be available to all your applications. Okay, so going back to the slides. Okay, so now we've kind of got used to like what LLM is, how you can define LLM configs, and we also introduced the chat model API. Let's now meet the demo application that we'll be using in the entire slide. So we have a company called Nexora, which is our running example. It's a mid-size e-commerce company that sells widgets, gadgets, and accessories. It does get a lot of customer support queries every day, and the current system is to do a it's an application, or it's a chatbot which does a if else routing based on what query the customer has sent, and it routes to specific static FAQ pages. Right. So something like that is there in the current application. It's a ColdFusion application in which, based on the rigid keyword matching, it sends you to different FAQ pages. And ultimately, if it couldn't find anything, it just gives you the support address that you could contact to. So this particular the current implementation of the chatbot is not accurate, and there are a lot of issues with it. We'll try to solve these issues one by one, and go ahead with it. Okay, so the first problem that we have is that the support, the current support that Nexora has, it is a 50 lines of code which breaks on actual questions, right? So if the real questions, the current system cannot handle it. So if the customer asks for what's your return policy if I bought it as a gift, it wouldn't know. With the keyword return, the it will go back to a generic fallback, so it doesn't match with the keywords. And if there are multiple questions in a particular query, it only handles half the questions, and it would not answer the other half of the question, right? So all of this could be solved by just 3 lines of code, which is using the chat model API. And what are the what is the benefit and how we can do it, we'll see it later. So this current code can be replaced by just 3 lines of code, and we'll see that in action as well. So what is achieved out of that is, it handles any phrasing of a question. It can answer multiple topic questions also. So if you have multiple questions in one prompt, it will answer that as well. And you don't need to, if there are new products or new policies introduced in the company, you don't need to make any code changes. The LLM can handle those. It responds in a natural language as well. But what it still does not do is, it does not know that it works for this company. It can discuss the competitors as well, and also there is no memory across the conversation. So we'll see the example, and I'll quickly go to the example. So before we go to the example, I have a sample app which can be used for like a sample playground kind of a stuff. AI, we can call this as an AI playground, where you could just try out all the features that I'll be discussing today. So, in the current one, we can just choose what provider and what model and give a prompt. It'll tell you this is the config, this is the exact code that we will be running once I hit run button. So we are just using the chat model function and returning the response from there. We can also explore the parameters by just changing the values of the temperature and see what kind of responses it gives. The max tokens, if there is less number of max tokens, the response is incomplete. But if you have more number of tokens, you will get a more complete token responses. So similarly, we can do a lot of exploration with a lot of parameters with this playground. So the chat model method, you just have to define your provider and your model along with the API key, and you can start interacting with your with the LLM. And with that, you can define certain chat model configs like temperature and max tokens to see the to tweak your LLM responses. Okay, so now we'll go to your basic uh, chatbot that we built with just those 3 lines of code. So I can use multiple responses, things like I can say, I can ask the chatbot saying that my item broke the first time I used it, and LLM can give very generic responses in a natural language. But if I ask about any competitor, the chatbot would also respond about the competitor, which is actually an issue. Since it's a chatbot for this company, it should not respond about the Amazon's return policy, or if randomly I talk about anything else, like write me a poem about a dog, it will even respond about that. So this is like one issue with the current implementation, and we'll see how we can solve that. Okay, so going back to the presentation. So we'll be talking about the next API. So we've been talking about chat model. We'll be talking about an intelligent wrapper on top of chat model, which is agent. And then how we can write system messages with this agent function. Okay, so moving on, what this agent wrapper, how you can write it is, you define the chat model and the config of the chat model. Once that config is defined, you return an instance, and that instance is provided as a config struct to this agent function. And the object that it returns, you can start calling a dot chat method to that object and start interacting with your LLM. Right. So again, pretty simple API which can be used, which is written as a wrapper on top of chat model. Now, chat model, what it was a single call. It was stateless. It did not have support of system messages. You cannot define memory, no tools. So it's a very lightweight wrapper, which can be used for just one-shot tasks. right? Now, with agents, you can define chat memories, you can define system messages, which will help the agent to remember the conversation and also to set the tone of your or the identity of your agent. Right. So in the example, you can see that I've set the chat memory and the max messages is 20. So that means that the agent will remember the last 20 conversations. And we've defined the system message as the you are Nexora's assistant. It should be more elaborate, but for just the demo purpose, I've defined this as the system message. You can also define the system message at the agent level or at the chat level as well. So at the chat level, you can again, it will be a struct which has two keys. The system message would basically be the tone or the identity that you want to set for the agent, and then your actual prompt goes inside this key, which is the user message. Right. So yeah, then we use this agent dot chat if we want a conversation management, or if you want to define the AI identity and rules. So by defining system messages, we use this agent API, and we can also define tools with this agent API, which we get to this in the later stage as to what these tools are and how do we use it. Uh, right? So with these tools, you could call your CFC methods and return those. The response of the agent will depend on the output of these tools, right? So the agent always requires the chat model, but and for model parameters and chat model configuration, you can define that inside the chat model function. But if you want chat memory, system messages and tools associated with your agent, you need to use this agent method. Okay. So with so in every conversation that you have with LLM, you can have two roles. One is the system role, which is basically to define the instructions or the job description that you can give to the AI. It can set the identity of the AI, the rules, knowledge, constraints that AI should follow. It should it's never known to the end user. It is only for the LLM to comprehend, and you can set it using the object of the agent. Whatever the object the agent app method returns, you can set that uh, with the dot system message method, or you could set it with along with the dot chat method. And the user message is basically the prompt that customers writes. It's the actual message from the end user, and you can pass it as an argument to the dot chat method. AI sees both the system and the user messages, but it never tells the end user about the system message. And with every dot chat method, you can either define the system message at the agent level or with every chat method. What your typical system message should look like. So you should define the identity of your agent. So you should tell it that you are in our case, you should tell that you are Nexora's customer support assistant. You can define what topics it should cover, what policies it should remember, so that whenever there are queries related to company policies, it can answer. You can set the tone of your system message. Since it's a support assistant here in this case, it should always be professional and empathetic. Then hard constraints: if the customer asks about competitors, you should decline politely, and for off topic, you should just again decline politely. And if you are unsure of any query, just escalate it to a human agent. Right. So these kind of uh, tones or these kind of messages you can add to your system message. So we'll see actually what we have written for our application. Okay. So what was our actual problem here? So in our current implementation, AI was a uh, helpful agent, but it did not know that it works for Nexora. So because of that, what happens is if someone asks for Amazon's return policy, it does discuss the competitor. It can give completely responses of completely off topic, uh, um, uh, like write me a poem about dog, and then you can. It actually does not know the return policy of the company it works for. Right. So for all of this, the solution is just to wrap the chat model inside an agent API and also define the system message so that AI knows its job description. So how we can do that is, again, we can define this post that you can define this as the system message. So in our application, we are defining this as the system message that your Nexora support assistant, you can help with these return policies, this shipping is this, and do not answer competitor questions. There are multiple other things that you can add to system messages so that AI has a unique identity and can answer accordingly to your application, right? And then post that when you send chat prompts to your application, it wouldn't respond to those ask about Amazon or random questions, it wouldn't answer, right? So let's see that in action. Okay, so before that, we'll just see the AI playground and see what we can understand about this feature, system message. So in this case, I have defined a persona, and in this, if I ask about, so this is my system message that I've set in the agent API, where I have defined it as a ColdFusion expert. So if I ask questions related to ColdFusion, it should give me a prompt response related to ColdFusion. But if I ask an off-topic prompt, it should not actually give me a reply. So if you can see that in an off-topic prompt, it just gave me that I'm here to help about ColdFusion programming questions, and it does not answer about Bangalore's weather. Right. So this is about system messages. Let's see that in our application. So if I go to problem 2, and if I ask about who are you and what company is this, it will give you details about that I'm from Nexora support. But now if I ask about Amazon's prices, it will politely decline, but it still does not have any memory. Right. So if I ask about what did I say in my last message, it will not have any memory about my last messages. So this is another problem that we are going to solve using chat memory. Let's get back to the application. Okay, right. So chat memory we'll see how we can add that to the agent API. It's basically a struct config that you will be adding to the agent call. In the simplest form, you can just define the max messages. In this case, we have defined the max messages as 20. So when you hit the limit, the oldest message will be automatically removed from the AI's memory. Then we have token. In the config, we have another key which is type, and that's defined as token window chat memory. So we support two types of chat memory: token window and message window. Token window is when you have messages of very different in size. Like instead of counting how many messages, you would set a token limit. In that case, we define a max tokens. But if the type was message window chat memory, where we want to define the number of messages that the AI should remember, the key is max messages. So you say type as message window chat memory and max messages as maybe whatever number you want to support. Right. Then we have one more key that is supported with chat memory, which is per user. So per user is critical when you have multi-user applications. So without that, all the users would share the same chat memory and the same chat history. and it is appropriate if you have a single user session, but if you have multiple users in your applications, and you would want the conversations to be isolated, you should be using this key per user, and it should be set as true. Right, and along with that, we also have the option of storing the chat memory to a persistent store. So there are four backends supported. We'll see what are those in the next slide. But to define the persistent store, the key that you need to use inside the struct config for chat memory is persistent store. Okay, so by default, if you don't use this key persistent store and you just use this as chat memory max messages, it is being stored in memory, and it requires zero config. It will be the fastest, but it goes when there is a server restart. It is not shared across instances, right? So it is good for dev and testing purposes. Then we have the support for cache, which is by default the caching engine for ColdFusion as well. And then again, it's no external server, no configuration required in this case as well. It would survive an application restart, but not a server restart. It can also work with CF clusters. So if it's good for a middle ground for most production deployments. But if you want to scale at a production grade, or you want a production grade choice, you should go for Redis. So this would survive even a full server restart, application restart. It would work in a CF cluster setup and all of that. For configuring the Redis, you can go to your CF admin, and just in the caching page, you can define the Redis configuration. And when you set the persistent storage as Redis, it will pick up the configuration from that page itself. Yeah, and the last one is Memcache. Again, Memcache again is similar to Redis, but it is also a cache, uh, right? And you can use this as well if you're comfortable with using Memcache and not Redis. Okay, so okay now, uh, I've already discussed what the current problem with the application is. It does not remember the memory of the previous or the previous messages. It does not have any memory. So for that, we can just add chat memory to the agent. We'll see, what code we'll be adding to our application. So we'll just simply add this chat memory config. We are using a very simple configuration here and not any persistent store. But if you want to scale it, it will just be a line of code change where you can just add that config as persistent store :Redis, and it will scale to start storing your chat memory into Redis. So once you define that in the agent API, the chat memory, it starts storing the conversation and it can remember your previous messages. So with this, let's go to the example and see how we've implemented it there. So we'll first go to the AI playground that I've built for chat memory. So I'll just press on the quick demo and it'll give you how it works. So it just gives you multiple prompts, and if you ask at the end, what do you know about me so far, it does remember that in this current conversation, the name was Alice and you love hiking and your favorite sport is tennis. So the chat memory uh, has a conversation history, and the simple line of code that we needed to add was to your agent API. You just need to add chat memory key with this config, and it remembers. You can play around with other settings as well. You can change the provider. You could change the memory type from message window to token window, as we have spoken earlier. You could change them per messages, per user setting, and all of that, and see how LM responds based on these configuration changes. Okay, then going back to our support, Nexora support. So we'll go to problem 3 that we had. Now, if I talk about my order, it still does not hallucinate about order details because it does not know about the order, but it will respond to me in a natural language about my order. And if I ask again what was the order number, it just responds saying that this was the order number. So it does remember the previous conversation. Right. But if I want to actually find out the live status of the order, which with Nexora, it will not be able to do it because it does not have access to the tracking system of this company. It is only answering from whatever knowledge it has been trained up till now, but it doesn't have access to the company or order details and all of that. So to solve that, we will be using function tools. So let me quickly go back to function tools. Okay, so now AI has been trained into a lot of data, but still it does not know about your company records. It cannot create a support ticket for you. For it cannot check the live inventory and so on, right? So for all of these, for the real data in your company, to know the real policies of your company, it actually needs access to your data. And for the agent to have access to that data, it needs to have function tool. Now, how function tool works is the customer asks this kind of query: what's the status of the order? Then LLM decides that it needs to get the order status of this. It knows that there is a LLM tool which is registered with it, and then calls that LLM tools. Once the LLM tool, which is basically a CFC here, so any regular ColdFusion component or any existing CFCs you have can also become a function tool CFC for your AI agent. So once you give the query, LLM decides that it needs to call the tool function tool to get the answer of that query. And once it has that answer, it goes and so it basically that CFC will be executed, and that result from executing that method of the CFC is sent to the LLM, and then LLM responds based on the results that it was sent from the function tool, gives an actual natural language response to the customer. You can also have multiple tools associate with your AI agent. So one AI agent can have multiple tools. You can just simply pass an array to the tools keyword. We'll see how we can do that. Uh, just a second. Uh, okay, I don't know why it stopped sharing. Just, okay. PPT is taking some time to share. So, like while it's doing that, let's go to the demo. So, I have multiple tools registered here with my AI agent, and I can choose multiple providers as well. So, I have two tools registered. One is a e-commerce tool, and the other one is a financial tool. And these are the tool functions that are available uh, with these CFCs. And you can simply call any of once you send a prompt to the LLM, it will actually go ahead and do a tool call, get the response from the function tool, and then respond based on the response that was given. So I'll just run that. Yeah. Okay. So while it's running, we'll just see how we can add that code. So this is just a simple CFC which has multiple functions in it, and it these are registered as a tool with your AI agent. So this brings us to the actual problem. So without access to your real data, AI does not know your order status or the policies of the company. So if the customer asks about your order or your policies, it would not reply. And for that, the solution is just to simply pass the agent to the tool CFC to your agent. And for that, you can it's a very simple change that you need to do with your agent application. Along with your chat model and chat memory, introduce another key, which is the tools key. And you can then add your CFC object to your tools array. You can have multiple tool CFCs registered to your AI agent. And once you have that registered, you can also define your system messages. You can start sending prompts to your AI agent, and it would actually go and execute the CFC method and respond based on the CFC method output that it receives. Okay. So let's go to the demo. So in the LLM response, like I told you earlier, there will be one more key along with the message, actual LLM message. There's one more key that we send to as part of the response object, which is the tool executions. So in this case, there were three tools that were executed as part of the prompt that was sent. The three tools that were executed was search software, then there was apply promo code, and then there was track order. So based on the prompt that I had sent, it executes these tools, gets the data, and then forms a response and gives it finally to the user. Okay, yeah, so you can choose multiple tools and then have multiple responses based on that. Moving on to our application, so we'll go to the next problem, which was the function tools. Now, in the earlier, we could see that it doesn't know about the order. So if I say, where is my order number, this, it should actually go and execute the CFC tool and give the data about the order. So if I see the active code, this is the active code. It registers this support tool, and finally the response that comes, it does give you the response about the actual order number. So if you want to see the code, I can show that as well. So for the function tool, you can see that this is the CFC that was registered with the function tool. And if I go to the support tool.cfc, the order number 12345 has this details, and these are the functions that are registered, that are defined in this CFC: get order status and escalate issue. So when the LLM got this prompt, it actually went ahead and executed this CFC method, which is the get order status. And the order status, if you see here, is this, and we are getting the same response there as well. Okay. Yeah, so that's what it helps. Now with each order number, we've associated an email address as well. So if anyone who gives a order number that is not associated with their email ID, they would also expose, the chatbot would expose the email of someone else's as well. So the personal information will get leaked. So if I just ask what email is on my account for this, it will actually go ahead and return an email ID, which it should not. So um, yeah, it just goes and tells you the email ID associated with this order number. And your production application should definitely not reveal any of your customers' email ID. So to implement this, we should have some certain guardrails associated with your AI agent, and we'll quickly see what those guardrails are. Okay, so going back to the presentation. Now, now the AI has access to real data, and it which actually creates a risk for your application. A over helpful AI assistant will actually go ahead and leak all your personal sensitive data of your customers, including their email IDs or maybe of their credit card numbers. So there should be a validation in place uh, that would actually block and redact the responses. And also, if someone goes and in the prompt adds their credit card number or their SSN, those input. So the agent should also not actually go ahead and store those kind of personal information in the company's data, right? So there has to be guardrails both at the input level and when you are sending a prompt to the LLM. The LLM should not store personal information like credit card information and maybe your social security number and so on. And there should also be a guardrail implemented at the response level, which is the output guardrail. So if someone asks email ID associated with the order number, the LLM should not give back the same response, the response with the email ID. It should actually go ahead and either block the call or redact the information. So for simplicity, I've only implemented output guardrails in the application, but you can have both input and output guardrails in your application. So how do you define a guardrail, output guardrail? It's simply a ColdFusion CFC, but the CFC should have a function called validate and should return a struct. And how you can like add that guardrail to your agent application, it is again just one key that you need to add to your agent config along with the other keys that we were writing before, like along with function tool, chat memory, chat model. There's one more key where we define the output guardrail, and it points to the CFC which implements this validate function. And this validate function should actually return a struct, and it should have multiple keys like success, success with, and error message. So the result should define these keys. And what you can validate with these with this function is you can validate patterns, personal information patterns like social security number, your credit card numbers, email ID. You can also block harmful content from your application, false promises that LLM could hallucinate about some brand claims and brand promotions, which is actually not applicable for your company. And you could validate that and block that response, block LLM from giving such responses. And also ask LLM, you can LLM could break some of your business rules and constraints, but that can also be validated with the guardrails that you defined along with your LLM, with your AI agent. Okay. So how it works is the agent, you send your prompt using this agent.chat method. The LLM generates the response. That response is sent to the output guardrail, which is basically your CF component with a validate function. And then the guardrail returns the verdict, whether it is successful or it redacted some information and sends a modified text, or if it has to completely block the response that LLM sends. Once that is done, it sends that to the LLM, and then LLM responds back with whatever message guardrail sense, so that the caller or the customer has a clean, safe response, or a block response if the guardrail simply failed with an error message. Okay, that's how output guardrails work. Uh, that brings us to the problem number 5 that we have with our current application. So, if the AI has access to function tools and no output filter, it could actually give details about your social security number, or if details about your account emails that we saw in the earlier example. So, to prevent that, you can add output guardrails to your agent, which would intercept and validate every LLM response. So, how do we do that is we simply create the objects of CFC object of your guardrail, and that is added to your output guardrail key. As simple as just adding one line of code and creating a CFC with a validate method. And then if you start giving prompts that should be blocked, the .chat method would give response accordingly. Right, so let's see quickly how we've implemented that in our application. So we'll first go to the playground and see guardrails there. So inherently, I think whatever LLMs are available in the market has some or the other guardrails implemented with it. So it will not respond back with harmful content, or content which is not good for you. So if I give something, if I run this with and without guardrail, the results will not be that different, because inherently all our models that we have available in the market has some or the other guardrails implemented with it. But you can see the changes here. So if I ask the customer, the AI agent about a customer record, to include a name and email address, and then the guardrail is implemented with the agent. So it will have a redacted before the raw LLM output will have the email address with it. But if you've applied guardrail to your agent, the email address will be protected and will not have that as a response. So we can see the guardrail CFC here, how we've implemented it. So we'll just go to the guardrail.cfc here. So we and it's a simple component like any other component that you have with ColdFusion. It simply has to have a function called validate, and inside it uh, takes an argument which is actually the response message from LLM, and you can write your own logic to return success or failure if based on the LLM response. So if it has something like a social security number, you would block it. If it had credit card numbers, you will block it. If you want to replace some of the email addresses with a protected text, you would redact the response and send the redacted response, and so on. So you can just write the CFC and add that to your agent API with key as output guardrails, and it should be able to give you the response with the guardrails. Okay, so that was the demo uh, in the AI playground. Let's go to our actual application. So if I go to the problem 5 guardrails, actually, it was working till morning, but somewhat I think it's not working currently. There is some issue with the application. Uh, I'll Before I upload it to GitHub with all the code, I will make sure that this is, it starts to work. But it has few issues right now. I'll fix that before I upload it to GitHub. But if the guardrail was in place, it would have given a redacted response where the the email ID of the order, email ID associated with this order would be somewhat like protected at the rate something. So you would not actually see the uh, email ID of the customer associated with this order number. Okay, so that's about guardrails. Yeah, just time check. Okay. Okay. So, moving on, now we'll talk about streaming and how you can implement streaming with your application. Right. So, streaming is not just for in ColdFusion is not just for browser visible typewriter effects. Like it's streaming whenever the tokens are uh, whenever you're receiving output tokens from LLM. It's just not for that. It is also for observability and logging mechanism. So every token and every completion, every error that can be captured in the LLM request and response, that can be captured using a handler CFC, and that handler CFC is attached using this streaming handler, which basically runs in the background whenever you send a prompt to the LLM. It gives you somewhat visibility into the LLM, and you know how what it does, how many tokens it is using, and when it fails, right? So again, streaming handler is again a CFC in ColdFusion, which should have these three functions, like the on partial response, on complete response, and on error method. So these three methods should be implemented in the streaming handler CFC, and this would what help you to increase your observability in what actually happened when a request was sent to a AI model, and it will log all the tokens that it received from AI. If there was some error, if there was partial responses, all of these could be monitored using the streaming handler. You can also use it to track your costs and calculate your actual API spend, because you would have an account of every input and output token if you define the streaming handler. It would capture all your LLM failures, which is good in case of debugging or for any kind of alerting that you want to implement. You can also detect or trigger alerts if the responses are very long or they're very short, so that could be also triggered using these streaming handler. You can have a good amount of audit trail related to all your AI responses, so that anytime a compliance is happening, you can use that audit trail and for all the compliance requirements. And as well as you can use it to measure the performance of your LLM provider, and also, and finally, the actual use case is to for browser streaming, so that you just don't see at a look at a blank message if the LLM is taking some time to form the whole response. You see, you are able to see the typewriter effect on your browser, right? So to implement all of these, you just need to have a CFC with these three functions. So we'll see what the CFC is. You should have this function on partial response, and inside that you can just simply write log with all the tokens that you are receiving. So uh, depending upon the provider, the on partial response typically might get 50 to 200 calls per response or per request that you send to the LLM, and the on complete response is only called once you have the entire response from the LLM, then it's just called once. But the on partial response, depending upon the output tokens, it may be called maybe more than 200 times as well in your application. And then there is an on error, which would basically log errors to your files if there is some issue uh, uh, with the AI streaming response streaming. And how you attach it to the agent, you can attach it again using the agent API, and you just have to add one more key, which is the streaming handler, and define the CFC that it would take. Right. So again, what was the problem here? It was that it was LLM was a black box here. We didn't have any logs. We didn't know what token counts for error capturing, cost visibility. All of that was not available to us. So for that, uh, if we didn't have stream handler, these kind of questions of token tracking, of error capturing, the length of the response monitoring, all of those will not be available to us. But we can achieve all of this using stream handler, and we'll see what we have done in our actual application. So I'll go ahead and show that code in your uh, in my code base. Just one second. Okay, so this is my chat model, and I've defined my agent with chat model, streaming handler, and system messages. Yeah, and apart from this, we can see the streaming handler as well here. So I have three methods defined here. One is the on partial response method. Uh, then we have the on complete response method and the on error method. If one of these function is also not defined in this component, your streaming handler will not work. So you need to implement all these functions in your component. So we'll go back to the example. Uh, so we'll first look at the AI playground, and we'll see how streaming works. So I can just do a start streaming here. Yeah, so gives you a kind of a typewriter effect as and when the tokens are received the by the AI agent, it just outputs that to the website here. And we'll see how we solve that in our application as well. There is some issue here. I'll fix that as well, but uh, there was some issue with this, and I was trying to fix it using Claude, and think it makes some mistakes. Keeps adding local variables to non-function code as well, so and hence it starts to fail. So yeah, I'll get that example as well fixed, and before I put it into the GitHub repo. Okay, yeah. The last example would be for MCP. So now, till now, we've known about function tools and how you can let AI call your code, or your get information about your data using function tools. And function tools are basically ColdFusion CFCs, which can be called directly. But uh, we can further go a step ahead by using MCP. MCP is basically Model Context Protocol. It's a standardized protocol that lets the AI to connect to any external service or tool, any external MCP tool server. So regardless of what language it is written or on what platform it is running. So we'll see how we can use it. So what MCP solves is basically what function tool could do was you could call your CFC directly, but the CFC should be there in your same server as from where you're making calls to LLM. But MCP can be AI call can MCP can be on any other server, and the MCP server can be not written just in ColdFusion. It can be written in any other language. It can be written in TypeScript or Python. So ColdFusion has the capability to connect to any of the MCP server that is written in any language, and it is running on any platform using the HTTP protocol. It's a standardized protocol which was developed using the Anthropic OpenSpec, and tools discovery with function with MCP server is very easy. You do expose a method called list tools, and AI knows about what tools are available with the MCP server. Using MCP client, you can connect to the MCP server, but one MCP client can connect to multiple MCP servers at once. So when to use CFC and when to use the MCP tool. So when you don't want any network overhead, or you have the simplest syntaxes written in CFC, when you just need CFCs and same server, use direct CFC. But if you want your function tool to be written in any language, running on any platform, or you want any external service integration, then or and you are okay to have a network hop per LLM call, then use MCP. And again, you can register an MCP client with the agent method, and that MCP client can be exposed to number of MCP servers at once. So the MCP server exposes a function called list tools. So MCP client can auto discover all the methods that are available in one particular MCP server. So for a good AI agent written in ColdFusion, you can have a mix of both. You can have direct CFCs as well, and you can have MCP clients as well that would point to an external MCP server. So we'll get into the details of MCP and all of that in another session that is going to happen tomorrow which will be taken by Piyush. So I'm not getting into a lot of details about MCP server client, how list tools work and all of that, but just to give you a context of MCP and how I've used in my application. So for writing an MCP tool, you can again, or the MCP server, you can write again in a with using CFCs as well. So you just have to have a CFC with you have to define a CFC, and then you have to use that CFC in your MCP server method. I can show that to you from the code samples that I have. So let me just go there. Okay. So this is the mcp.cfm file. So in this, I am defining my MCP client. And in the MCP client, I have defined something called a custom URL. And that URL points to a MCP server, which is this server. Okay, and then I have other configurations that I think Piyush will get into details of those. But this is how you define your MCP client using this MCP client method. And the transport type can be either HTTP or STDIO. In my case, it could be STDIO as well, because I'm using a ColdFusion CFM file only. But I've used HTTP protocol itself here. So this is my MCP server. I can go to my MCP server and see how it looks like. So this is my MCP server. This is my server config. I have the name of the server, version, what capabilities it exposes. So tools is true. So it does expose certain tools. And for tools, I have these CFCs defined. So basically, these are my MCP server tools that is associated with this MCP server. And these are the two tools which is actually CFCs. So one of the tool is this financial tool, and the other one was let me go back to this. This was a e-commerce tool, which is under AI testing tool. So it's in another folder. So I can just show it to you, the finance tool. So finance tool has certain functions, and which the LLM would use to execute, and from that response, it can actually go and send the response to user queries. Right. So we'll see how we've used it in our application. So we'll go back to the demo. Okay, so we'll go to the MCP, the AI playground that I have. So in this, I can do a list tools. So it just calls MCP client dot list tools, and it can tell you that these are the tools that are available with your agent. And these are basically 9 tools. This is the MCP client code. So the same code that I showed you now. And this is the server CFC. So I can just call any prompt. I can say this or wrong item received or something like that. And then I can chat with the MCP tool. It will execute one of these tools. And since it says MCP assistant, that means one of the MCP tools was called, and that's how it got the order ID details. Okay, so we'll see a similar example with our application. So in our current application, sorry, we didn't have any ways of logging tickets for any orders that uh, needs human attention. So if I say I want to escalate a issue with order this, so it goes and actually calls the MCP tool. We'll see that how it does in the code itself. So yeah, so this is my MCP client here, which calls this MCP server. So if I go here, this is my server, and this calls this ticket tool CFC. So the tools attached with my MCP server is ticket tool, and this is my CFC, in which has this file ticket function. And this function actually goes ahead and sends an email about whatever ticket is getting logged. So I can go back and see that this was the ticket logged, and this is the ticket number. An email would have been sent to me, and within like 2 hours, a senior support agent. So this is how your support system or the support chatbot should also behave if there is some escalation in any ID, or if you want to actually log a ticket. So it went ahead and used the MCP tool that is it is exposed to. Right. So if I ask any other questions about uh, the return related to returns or warranty covers, it wouldn't have any idea about it because it is not trained on the company policies. So in the system messages, you saw a very small assistant that was written about the returns, but it did not have any, warranty coverage. So for all of these kind of data where the agent should know details about your company policies, you that then comes the need for RAG. So we'll quickly look at the example of RAG since I'm running out of time. I'll just quickly show you how RAG works in the AI playground, and then show that same example with our current application that's running. So I've already ingested these docs, which is related to Adobe products and company policies. You can see those docs here. So these are the products, and then there is some ColdFusion guide and company policies, which tells you what features are available with ColdFusion 2025 and company policies. Okay, so if I ask anything related to these docs, it should go ahead and use the RAG pipeline and get data from these documents and then reply. So if I have to ask about, you know, the price of CF, what is the price of ColdFusion 2025, which is mentioned in one of the docs. Yeah, so it does mention as 1299 for a one-time license, which should be available in the docs. Yeah. Yeah. So one-time license is 1299. So it did call the docs and got the information from there. So we can quickly look at how we did that. So we'll just see the code of the chat model. So again, we have an agent here which has this chat model config. We have defined the chat memory, and this is where we've defined our RAG. So this is an advanced RAG code. We'll get into details of how this works in the next session. I'm just giving you a base idea of how RAG works, and then we can get into the details in the next few sessions. So we define the source of all your documents here, the embedding model that will be used to break down these documents into chunks and then into vectors and store it in a vector store. Here, my vector store is in memory, and then I have a query transformer type as compressing. So you see, what kind of RAG. This is for the advanced RAG. I also have a RAG for simple RAG use case in which we just use the simple RAG method and not define this along with the agent API. So we'll just see the two use cases. And before that, let me go back to the application. So I go back to RAG, and then I was using simple RAG. I can move to advanced RAG and then ingest the docs. So it just ingested these three docs. Now I can say what is the return policy for the products, and it will tell you the return policy. But if I ask another question, which is not very clear, the simple RAG would fail here. But since we have an advanced RAG and we have query transformation enabled with the advanced RAG, it will have knowledge about your previous conversation and will be able to answer this as well. So it did answer about the return policy of the digital downloads. So in the first question, we asked about the return policy of physical products. And in the second, we did not mention the keyword return policy, but it did know about the return policy. This is because we are running in the advanced mode and the query transformation is enabled here. Right. So, yeah, that's all I had from my side. I can give you the entire code, share the entire code with you guys.
Awesome. Thank you, Suchika. That was amazing and a lot of code. It's so cool. We do have a question for you in the Q&A from, I think it was Rick Mason. I had assigned it to Nimit, but I'm not sure if Nimit's there. But basically the question is, will we be allowing the LLM config to add non-supported models? Oh, Nimit just answered. Okay. Nice timing, Nimit. Nimit says this option is not supported as of now. We can consider if there's enough. Okay. Okay. Sorry. Go on. Do we have any other questions from folks? Cool. Okay. Awesome. Well, this has been recorded. It will be put onto YouTube here in a day or two. Please make sure that you continue coming to our webinars. We've got them going for basically the next 7 days or so. So we look forward to seeing you there. Thank you so much, Suchika, for the amazing talk. And do you know where will you be able to post your code thing? Is it going to be on the Adobe ColdFusion GitHub?
Yes, it will be available on Adobe ColdFusion GitHub. We'll share the links. I think Charvi will share it with you guys. But we'll be posting all our code samples and the sample applications that we are building as part of the webinar.
Awesome. Awesome. Sounds great. All right. I'm going to go ahead and